Hey Mr. Ebell, here's my third and final video on second law applications to, and I have an elevator problem that could be solved. So here, uh, I'll just state this now for reference. If I have a negative number, it's either going in the downward direction or to the left, and if it's positive, it's going to the right or an upward direction. And just because it's an elevator, we're only going to be dealing with the upward direction or the downward and the upward direction. So no need for left or right. Alright, so here we have let's call this stage 1, our elevator's at rest. And let's put gravity G equals negative 9.8 meters per second squared. And let's find, since it's at rest, it's at rest, so its velocity is 0 and acceleration is 0. Let's say this person, this happy person, has a mass of 10 kilograms. That's 10 kilograms. And so, that looks like 8. There we go. He has a mass of 10 kilograms. So, right now, we could find the force of gravity that's pointing downward. We could find this force by F is equal to, not times, M A. So here, from here, we can multiply our acceleration, force, the gravity, times our mass, 10 kilograms. So that would equal up to about, negative 98 meters per second. F G, if we can get the G working, equals negative 98, not meters per second, but 98 newtons. Write that better. 98 newtons. And this gravity is going to be is the same for every other stage we have. So this is negative 98 newtons. This is negative 98 newtons. Because this gravity is constant, even though we'll just say this gravity is constant, although the gravity changes at different heights. So let's just say it's constant. And now let's move on to stage 2. Let's say he's on the first floor and he wants to get up to the third floor, or excuse me, fourth floor. Just say that. And once he starts, his elevator accelerates for 3 meters per second squared. He accelerates for 1 second at 3 meters per second squared. Oh yeah. Here, his normal force is just inverse. Sorry, I messed up his face, but it's inverse, or not inverse, but the opposite of force of gravity, because he's at rest and he's feet. Well, they're technically not on the floor, but let's just say that it's on the floor, and so at a 90-degree angle, so the force of gravity, the opposite of force of gravity, is equal to the normal force. So F N equals 98 N. So now let's move on. So here, if we want to find the normal force of our person at stage 2, we know that the force of gravity, well, the F net has to be greater than the force of gravity. So we have that now, and we don't know what F net is, but we do know that force of gravity is negative 98 newtons. And to find out our F net, we could take our acceleration right here times our mass up here. So, and then 3 times 10 equals 30 newtons. 30 newtons. And so you might ask, where do we add these 30 newtons? But if these 30 newtons is the difference, or we could say the sum, or no, the difference of F net well, actually this is the F net, excuse me, but the normal force minus, well, plus force of gravity. So all together, and change this so to normal force. Messed up that. I just need it now. Now I know my error. This is normal force is greater than force of gravity, and 30 newtons is our F net. And if we want to find our normal force here, we can take our gravity and add it to, actually subtract it from here, since this is a plus sign. We can subtract it and to the F net to find the normal force. So doing some mental math just to do it, just save space. F normal force at stage 2 is equal to 128 newtons. Let me draw that better. 128 newtons. And now we have our normal force for stage 2. And here, okay, now we can move on to stage 3. 1, 2, 8 newtons. Now let's move on to stage 3. Let's is that here at stage 3, his accelerating has stopped after the 1 second of acceleration, so he has a velocity of 3 meters per second. And for actually, for to find this normal force, it's quite simple, because at stage 1 and 3, the normal force are equal, because with constant velocity, you're inside an elevator, you have no point of reference. So constant velocity and being at rest feel the same inside of an elevator. So we already know, so from that, we know our normal force is 98 newtons. 90, and our F net is 0. And now let's move on to stage 4, where this person's elevator is slowing down. So it's decelerating at negative 3 meters per second squared. Let's draw the units again. Sorry for this. Meters per second squared. How much time do I have? 12 minutes, more than enough. So from there, so now that we know that it's decelerating at this speed, and just switching it, taking what we did for stage 2, let's do mass, or acceleration times mass, times 10 equals to net force, negative 30 newtons. And this is the difference between, is equal to F N plus F G. Those are the only two forces applying in this problem. And if we could find the normal force the same way we did in the beginning, or not beginning, but stage 2, where we added force of gravity, or subtracted the force of gravity to the net force, and this normal force would equal to is equal to 98 newtons minus 30 newtons, because we subtract force of gravity to both sides and a negative times a negative, because gravity is already negative 98, so that would make it a positive 98. So subtract 30 newtons, and we get our normal force is equal to 68 newtons. And there we go. Let's draw just in reference of the other ones. So 68 newtons is our normal force for stage 4. And at this point, he reaches his floor at 4th floor. So there we go. Hope this is long enough. Let's see. It's way longer. Alright.